So this is lecture number 28, I think, for Wednesday, the 8th of April. This will be our very last lecture, and I'm going to try and keep it abbreviated since Monday's was a bit too long. What we've covered so far have been resistor circuits, RC circuits, resistors and capacitors, also capacitors by themselves. We've done inductors with capacitors, and is that all the combinations? We've done LC circuits, LR circuits, CR circuits, and R circuits. What if we have all three together? And this would be a much more realistic version of a circuit. Even if we didn't connect a physical resistor to a circuit with an inductor and a capacitor, the wires and the inductor itself would still have some resistance. So we need to be able to include resistance in a circuit with an inductor and a capacitor. So how are we going to think about that? Well, let's think about what resistance is. Resistance means resistance to current flow, and we get energy dissipated through means of heat energy or conversion to other forms of energy. It's kind of like friction in a physical system, so you get a loss of energy into heat or other things. So what does that mean for an LRC circuit? What it means is, let's say we start with a charged capacitor and we let the charge starts to flow. The charge is going to start to move around. It's going to transfer energy from the electric field of the capacitor to the magnetic field of the inductor. But there is some energy loss through the resistor, so the amount of energy that's transferred to the magnetic field is going to be less than the original energy that was in the capacitor. Then it's going to transfer back from the magnetic field of the inductor to the electric field of the capacitor, but it will be a little bit less again. What would that energy look like over time? Well, what would happen is that the energy would oscillate, but it would get less and less over time. So we could measure the energy, and we could represent that energy by measuring the charge on the positive plate of the capacitor. The charge on the positive plate would go from initially the original charge, it would vary down to some negative charge, back up to positive, down to negative, and it would get less and less over time. The amount of energy stored, the amount of charge on the plate would lessen over time because there would be less energy stored in that electric field. So what we would get is a damped motion, just like we have with masses on springs, where you have some damping in the system. Same thing happens here where the damping is introduced by the resistance. And of course, you can get critically damped circuits. If you have a larger value of the resistance, the amount of charge would die off very quickly and it wouldn't oscillate at all. You could also have an overdamped circuit where you had a very large resistance and the energy would still die off without oscillation, but in a different way. Okay, next we'll go into analyzing the equations and we'll do an example or two.